Okay, our last topic was OSPF implementation. Remember?
Yes,
OSPF implementation. Okay. And we complete our OSPF basic lab. OSPF basic lab. If you remember the concept of OSPF, we can create area zero first. Area zero is called backbone area, or you can say transit area. If you are creating multiple areas, then all the areas must be directly connected with the area zero. This is the concept, right? You will see.
yes,
Now, now let's use a different topology now today, different topology today. And into this design, we have one area. We have one area, and this area is not directly connected with the area zero. Let me create a design. So into this design, we have multiple areas. Okay, we have area zero. This portion we are using as an area zero. Now we have area 10, area 10, area 20. Let's define IP address configuration first. So here I'm using 10.1.12.0/24. Okay, this one is a part of area zero.
look back.
Now we have area 10, 10.1.23.0/24. Now we have 10.1.34.0/24. And this one we are using in area 20. Now for roots, let's create some loopback interface. So 1.1.1.1/32, 192, 168, 10.1/24. So I'm creating two loopback interface on R1 router. Okay, let's go to R3, and I'm creating two loopback interface here, 3.3.3 and 192.168, 30.1/24. And these loopbacks
Okay.
I will advertise. These loopbacks I will advertise into area 10. Now we can create loopback on R4. So 4.4.4.4/24 and 192.168, 40.1/24. So we have loopback interface here. Now let's try to configure IP address on routers, and we can advertise our network in OSPF area as per our design. UNC. Clear my point?
Yes, yeah.
Let's try to advertise our routers in OSPF area as per design. So we have R1, R3, R4. Okay, let's access R2. So into this design, I'm trying to configure IP address configuration. We can start our configuration with R1 router. Let's start our configuration with R1. Show config the interface fast Ethernet 0/0, 10.1.12.1 mask, no shutdown. Interface loopback interface 1.1.1/32. We can create loopback 192.168, 10.1 mask/24. Show IP interface brief. Let's advertise our network in OSPF area. So router OSPF process ID 10.1.12.0. As per design, we are trying to advertise into area 0. Now 1.1.1 loop back into area 0.
Mm.
192, 168, 10
Then
dot 0 into area 0.
area 0.
Let's go to
Okay. Now
R2.
two.
Fast Ethernet 0/0, 10 dot 1 dot 12 dot 2. Mask, no
Mm.
shutdown. 0/1, 10 dot 1 dot 23 dot 1.
One.
Now, no shutdown. Now, we have two interfaces. Show IP interface brief. Now, router OSPF process ID 10 dot 1 dot 12 dot 0, 12 dot 0. Areas
Area.
10 dot.
Area 10.
Yes, yes, 12. Any question?
Ah, yeah, yeah. Yeah, yeah. No, no. You're right. On that area, on that IP, we are on area 0. Yeah.
Sorry, can you repeat your question
Because,
again?
no, I say for that the IP 10.1, 10.12.0 is on
Yes,
area 0.
it's a
That
part of
means
it.
this one, yeah, this one will carry to
23 is a part of area 10.
area 10. Yeah.
Okay,
Okay.
yes. And advertise these networks, this network into area 0, this network into
Now
area 10. Okay,
10.
let's
Yeah.
go to R3 router. And on R3, we have two physical interface and two loopback interfaces, 0/1, 10 dot 1 dot 23 dot mask, mask, no shutdown. Now 0/0 interface, 10 dot 1 dot 34 dot 1 mask, no shutdown. Show IP interface brief. Now we can create
Mm.
loopback interface. Interface loopback 0, 3.3.3.3 mask, interface loopback 1, 192, 168, 30.1 mask. Now show IP interface brief. Let's advertise our network. Router OSPF process ID 10 dot 1 dot 23 dot 0. Wildcard mask area 10. Yes, area 10. Now
Okay.
network 10 dot 1 dot 34 dot 0. Wildcard mask area 20.
Area 20. Yeah.
Now 3 dot 3 dot 3 dot 3. Wildcard mask area 10. I'm trying to advertise in area 10. Both the loopback interfaces. Now 192,
Oh.
168, 30.0 network into area 10. Now let's go to R4. R4 fast Ethernet 0/0, 10 dot 1 dot 32.2. No shutdown. Interface loopback 0. 4.4.4.4. Mask. Interface loopback 1, 192, 168, 40.1. Show IP interface brief. Let's advertise our network router OSPF process ID 10 dot 1 dot 34.0 wildcard mask area 20. And yes, we have some loopback interface 4.4.4.4 into area 20, 192, 168, 40.0 network. And I'm trying to advertise into area. Any problem in IP address configuration or root advertisement?
No, no, no,
Simple task, right?
no problem.
It's a simple.
Very simple.
Now, now, let's start our verification. If you remember OSPF concept, in OSPF concept, in OSPF protocol, we can create area. What is area? Logical grouping of routers. So we can create area and we need to create area 0 first. Why? Because area
Yes.
0 is called backbone area. It's a transit area. And if you are creating multiple areas
Mm.
in your design, you are creating multiple area, then all the area must be directly connected with the area 0. This is the rule, right? This is the rule.
Yes.
So now
Mm.
into this design, if I'm trying to verify route information here, show IP route OSPF. If I'm trying to verify route information right now, so yes, I'm receiving some route. I'm receiving some route from R3. See, 3.3.3
Yeah.
back, 192.168.30 network, 10.1.23 network. And yes, area 10 is directly connected with the area 0, right?
Yes. Yeah.
R2 is acting as a ABR router. R2
ABR. Yes.
area ABR router, area border router in between area 0 and area 10, right?
Mm. Yeah.
But I'm not receiving any route information from R4. I'm not receiving any
Okay.
route information from area 20. See, I'm not
Mm.
receiving 4.4.4.4 loop back. 192.168.40 dot network. No, I'm not receiving.
Mm.
If you go and check on R4, for example, if you go and check on R4, show IP route OSPF, so you can see you are not receiving any route information.
Mm.
Check
Root
show IP
information.
OSPF neighbor. Yes, you have a neighbor relationship. You have a neighbor
Yeah.
relationship with R3, but you are not receiving any route information. Why? Because area 20 is not directly connected with the area 0.
Okay.
Okay.
Yeah.
So what we can do into this design? What is the solution? What is a possible solution we can do? Because I'm working in a design where I have some areas, and these areas are not directly connected with the areas. So what is the possible solution? Let's go with the slide. What is the possible solution we have uh, for this problem? Wait. Okay. So now what is the possible solution? First solution, we can extend area. This is the first solution. What? We can extend area. It means what we can do, no need to create area 20. Hear my point? No need to
Okay.
create area 20. You can extend your area 10. You can extend your area 10.
Okay. Okay.
But if you are extending your area 10, then if you are extending your area 10, then
You need to change
in area you
configuration
have a
from
lots of
browser.
routers, right?
Yes.
And they will maintain equal database.
Mm.
Okay, this is the problem. Now. First solution is what? Extend area 20. And I cannot extend, for example, because I have some lower series of router, I have some high-end router. Okay, and if I'm trying to extend my area, all the routers will maintain equal database. I have some low-end router,
Mm.
cannot maintain a big routing table database. That's why I cannot extend. Okay.
Mm.
Now,
Mm.
next solution, physical link. Connect a physical link from area 0. What is the next solution? Next solution is, wait. Now, what is the next solution? Connect a physical link. Connect a physical link with area 0. And maybe it's
Mhm.
not possible in your design, okay?
Yeah.
Area 20 is a part of any other branch, and area 0 is a part of any other branch. And it's not possible to connect a physical cable, physical link. Then what is the next
Mm.
solution? The next solution is our topic today, and this is called configure virtual link. So you need to configure virtual link.
Okay.
This is our topic. Topic is what? OSP of virtual
Virtual link.
link concept. So what we can do in virtual OSP of virtual link? So we can logically trying to extend our area zero logically, okay, not physically, okay. We are trying to extend our
Okay.
area zero logically to R3. And if R3 is a part of area zero logically, it means area 20 is directly connected with the area zero.
Yes. Yeah.
So what we can do into this design, wait. So what we can do into this design, we can create a virtual link. For virtual link, what you can do, for virtual link, what you can do, identify the virtual area first. Identify the virtual area first. And which one is a virtual area? So in between, in our design, in between area 30 to area 0, we have this area 10.
Um,
So area 10 is what? Our virtual area. Clear my point?
virtual link is 10, right?
Area 10 is what? Our virtual area, because in between area 20 to area 0, we have one area here, right?
The pass through,
So
yeah.
this area will act as a virtual area. Now, when you get your
Vir-
virtual area, when you get your
mhm.
virtual area, what is the next task? Next task, try to identify border routers.
Mhm.
Border.
Or
So this is our virtual
yeah,
area.
yeah.
And yes, we have border routers here. R2 is a area border router. R3 is a area
Okay.
border router. So we have two border router here. So first step,
Mhm.
try to identify your virtual area. Next step, once you find your virtual
The
area, try to find border
the
route
border
in virtual area. So we
router.
have R2 and R3. And what is the
Mhm.
next step? What is the next step? Exchange router ID. Exchange router ID with area virtual link command. Exchange router ID.
Mhm.
Exchange router ID information with virtual link command. So what I'm doing, let's go to R2 first. And if I'm trying to verify router ID information, so command is show IP protocol. This is router ID, UNC. Clear my point?
Okay. Yeah. Yeah.
R2 router ID. Now, if you go and check R3 router ID, show IP protocol. So yes, 192.168.30.1. This highest loopback interface is acting as a
Yes. The
router.
IS look back. Yeah.
Yes. So now this
Mhm.
one is a router R2 router ID. This one is a R3 router ID. We need to exchange the router ID information with virtual link command. Now,
Okay.
now we can exchange, no problem. We can exchange router ID with virtual link, no problem. But the point is, here we have router ID, and you can see why this IP address is acting as a router ID 10.1.23.1, because this interface is having highest physical interface IP. That's why this one elect as a router ID for R2, right? You can see,
Yes. Yes.
right? So here, see,
Yes. It's right.
the problem is if problem is what? Once you exchange router ID information, router ID information with both the routers with virtual link command, no problem, you can do this. But the point is, after 1 month, after 2 months, administrator create here a new loopback interface, for example. And this
Yes.
loopback interface is, for example, 5.5.5.5. Once you create
The
your loop
IS one.
interface, so remember router ID. Once
Yes.
if you have loopback interface, then router will not go with the physical interface IP, right?
Physical interface. Yes.
So after 1 month, after 2 months, If any administrator will create a loopback interface here, then router ID will change here. And once router ID
Then
change,
you lost. Yeah.
then yes, you will lost your virtual link.
Mm,
You will lost your virtual link. That's why into this scenario, you need to create, you need to go with the manual router ID. You will see.
okay.
For virtual link topic, you need to go with the manual router ID. So what we can do, we can go with the protocol router OSPF process ID. And what is the command to configure manual router ID? Router ID is a command.
Mm,
Router ID. So I'm giving router ID, for example, 22.22.22.22. Once you press enter, you can see you are getting a message. Try to reload your router or use clear IP OSPF process command. So I'm not restarting this router. Okay, I'm using what? Clear IP OSPF process.
process.
Let's go to R3. Let's go to R3 and I'm trying to configure router ID manually. So router ID, for
Oh,
example,
okay.
33.33.33.33. Now clear IP OSPF process. Clear IP OSPF process. Now let's verify router ID this time. Show IP protocol. So 33.33.33.33. Show IP protocol. You can see 22.22.22.22. Now we can
Yes.
exchange router ID information with
Mm,
virtual link command. So what you can do, you can go to router 2 and what is command? Area. So
mm,
which area you want to use as a virtual area right now into this design? Area 10, right?
yes.
Area 10. So I'm using what? Area 10. Now question mark. Here is a command. Here is a command what?
Virtual link.
Virtual link. So virtual link. And what is R3 router ID? 33.33.33.33. Let's go to
Okay.
let's go to R3 router OSPF process ID area 10 virtual link. And what is virtual link? What is router ID of R2?
22. 22.
22.22.22.20. Done. Done your configuration. And
Okay.
if you go and check on R1, for example, this time, R1, show IP route OSP, you can see. Now I'm trying to verify on R1. I'm trying to verify on R4, show IP route OSPF. So on R1, this time, yes, I'm receiving route information from R4C.
Yeah.
You can see clear my point.
Yeah, very clear.
Now, if you go and check on R4 this time you are receiving all the routes
Mm,
from R1, R2. So logically, we extend this area 0. We extend this area 0 to here. Now, please help me, Juvency. Please
yeah.
help me in case if I have one more router here, okay? One more router, and this R4 is connected with R5, and and this one is a part of, for example, area 30.
That, that was my question. Yeah. Yeah.
Now,
So I was preparing to ask this question. If we
no
have
problem.
more area
No
in
problem.
the middle.
Now, so no, now in case if I have one more area here, okay, 10.1.45.0, and now it's the area 30. Now, what we can do, because area 30 is not directly connected with the area 0, okay, right? So
Yeah.
let's go.
Mm,
Let's go here R4 first. Okay, wait. Let's go with the R4. So I'm trying to configure IP address first on R4 router.
R4. Yeah.
Interface fast Ethernet 0/, and you will help me in 45.1. Let me configure IP address, and I'm trying to advertise network 10.1 dot 10.1 dot 45.0 area 30. Let's go to R5. R5. Now 0/1. Now 10.1.45.2. Mask. No shutdown. Show IP interface. Show IP interface brief. Router OSPF process ID 10.1.45.0. Let's advertise in area 30. Now show IP OSPF neighbor. I'm not receiving any information. Show IP route OSPF. I'm not receiving any information. I think let me check is 0/. So
You
we can
can
get neighbor information.
you can add the loopback.
Yes, we can create loopback, no problem. Interface loopback 5 dot
Mm,
5.5.5.5 mask, and this loopback I can advertise. I can advertise in OSPF protocol 5.5.5
mm.
area 30. Now I have a neighbor table. If you check, I have a neighbor table information, but I'm not receiving any route information from R1, R2, R3, and R4. So now
Okay.
please help me for this solution. What we can do now? Area 30,
Okay.
area 30 is not directly connected with the area 0, right?
Yes.
And we logically extend right now, we logically extend our area 0 here, I think. Remember, it is
Yes.
already extended. Now what we
Yes.
can,
Already.
you can say it's a logically area 0, this portion. So in between
Yeah.
area 0 and area 30, which one is a virtual area?
Yes.
Area.
Thank you. That's why I was thinking. We need you need to create a virtual link between R3 and R4.
Yes, yes. See, yes, you can, what you can do, you can, here we have loopback, and here we have router ID 33.33
Yes.
dot 33, right?
Yeah.
And on R4, yes, we can configure router ID manually. So let's go to
Oh, yes.
R4
Yeah.
router
R4.
ID, for example, 44.44
Because-
dot 44.
yes.
Clear IP OSPF
Process.
process. Now we can verify, show IP protocol, and yes, router ID is changed. So now this one is a virtual area. And if this one is a
Virtual.
virtual area, so R4 and R3, these two routers are what? These two routers are
Border.
right?
Border router. Yeah.
We can exchange router ID information with
Yeah.
virtual link command. Okay, so let's go to router OSPF process ID. Command is area. And what is virtual area name? Area 20, right?
20. Yeah. Virtual
Virtual
link.
link. So I'm on R4, 3.33.33.33.33. Let's go to
Yeah.
R3 now. And on R3, we can go to OSPF protocol, area, area 10,
Mm,
virtual link, 44.44.44.44. Done. Done. You can verify now. You can verify now here on both the routers. Let's go to R5 now. R5. And here I can check my routing table. Before check my routing table, let's go to R1 first. And on R1, this time I am receiving, wait, it's taking time. I'm waiting for 5.5.5 back. I'm not receiving. Please wait. something mismatch here. Let me check. 10 dot 1 dot 32 dot 34
I
dot.
think it's the area for R3. You set to area 10, the link, virtual link.
Let me check. 30 virtual link not.
Normally,
Wait. Show IP protocol. 33 router ID here. Okay. So run pipe section OSPF. So let's check configuration first. So on
yeah,
our
the virtual link
we
should
have
be our area 20.
okay. This is the mistake. Okay, area 10.
Yeah,
This is the mistake. Thank you. Router OSPF 5. No. So now we can change area 20.
20.
Area 20.
Yes.
Now we are getting a message loading to full and we can check now on R5. Show IP route OSPF. Okay, I'm not receiving. Please wait. Yes, I'm receiving now. See,
Now you can listen. Yes.
R5 loopback interface on R1. On R1 router. And if you go and check on R5, show IP route OSPF. So you can see you are
Mm,
receiving complete information. This is our
yeah,
topic, virtual link. Clear now?
very clear.
Okay, let's go to slide now. Wait, give me 2 minutes. So we complete our OSPF area concept, multi-area design. Area must be a backbone area. Get this one area, it's complete. Root summarization is complete. Virtual link. Okay, now virtual link. Okay, now let's talk about, you will see, OSPF
Yes.
network type. So in OSPF,
Type.
we have
Yeah.
network type here. We have first one is called point to point. Second one is
Mm,
called what? BMA network, or you can say broadcast multi-access. NBMA, it's a old technology, okay? So no one using NBMA network type. Frame relay,
okay.
ATM, X.25, these are old
Yes.
technology, okay? So you will not get these options. You will get only these two options here. This is called point to point. It means
Actually,
are connecting your devices with serial link. You can see you
yeah.
are connecting your devices with serial link. But nowadays, we are using Ethernet technology. We are
Yes.
using Ethernet technology to connect LAN portion, WAN portion. Ethernet is a popular option. So whenever
Mm,
you are connecting Ethernet technology, whenever you are connecting your devices with Ethernet technology, this is called BMA network, broadcast multi-access network. Let me show you. Let me tell you this point. So what is broadcast multi-access network? In broadcast multi-access network type, it's like a LAN technology, okay? You can connect your devices with Ethernet technology. And into this network type, DR, BDR election are required.
required.
Required,
Okay.
yes. This is what example of this is the example of broadcast multi-access network. DR, BDR elections or selection are required. And OSPF detect this type of link automatically, you will see. Automatically.
Yeah.
No need to tell anything. Okay, let me show you. Let me show you this option. For example, into this design, I'm using Ethernet technology. So if you go on R1, for example, and if you type show IP OSPF interface, fast Ethernet 0/0. This one is a great command for OSPF. Show IP OSPF. It's a great command. And you can go with the interface name. Why this command is a great? Because this command can give you a lots of output, a lots
Mm,
of information you can verify with this show IP OSPF command. Let me show you. So this command can show you the interface. See, fast Ethernet 0/0 is up, line protocol is up. What is IP address? And this IP address is advertised in area 0. What is process ID? What is router ID? Okay, what is network type?
Okay.
What is network type?
Broadcast.
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 Automatically. Link automatically detect. It's a broadcast, BMA network technology, Ethernet technology. If you are connecting, for example, if you are connecting your devices, if you are connecting your devices with serial port, for example, let's connect with the serial interface. So I told you link automatically detect this devices, okay? So we are using serial port in between R6 and R7. I'm trying to configure IP address. We can advertise these routers in OSPF area. Let's go with R6. So as per design, interface serial 1/0, 10.1.67.1, mask, no shutdown. I'm trying to advertise in OSPF, router OSPF process ID 10.1.67.0, wildcard mask, area 0.
Hmm.
Let's go to this into this router, serial 1/0, 10.1.67.2, mask, no shutdown, router OSPF process ID 10.1.67.0, wildcard mask area. So you can verify now, show IP OSPF neighbor. This is point-to-point connection, you will see.
Okay.
Whenever you are connecting your devices with serial port, this is called point-to-point connection. And in point-to-point connection,
Okay.
in point-to-point network type, there is no DR and BDR selection process. No. If you check
Hmm.
show IP OSPF neighbor, you have a state information only.
Full.
You have state information only. You are not getting only any DR, BDR information you see.
Hmm.
You will see. Clear my point? You
Yes, it's clear.
can also verify on R6, show OSPF neighbor, you have only state information, but you're not getting
Yes.
a DR, BDR option here. Now, let's use show IP OSPF interface serial 1/0. So you can see now, I told you, I told you
Hmm.
link OSPF detect this type of link automatically.
Okay.
So if you go and
Hmm.
check here, if you go and check, show IP OSPF interface serial 1/0,
Okay.
type is what?
Point to point. Point to
Automatically.
point. Yeah. Okay.
Automatically it will detect. Now let's go to slide here. So we have two network type, point to point and broadcast multi-access. Now let's go with that. Okay, let's talk about relation. Let's talk about relation. So here we have some routers into this area. This one is acting as a DR. This one is acting as a PDR. This one is acting as a DR other. This one is acting as a DR other, DR other. Now, what is the relation? So DR BDR relation with DR other is a full. DR other
Okay.
relation with the DR BDR is full. And remember, one DR
Yes.
relation with other DR is only what? Two.
Two way.
Now, what about updates? So I told you in OSPF, the OSPF protocol uses two multicast address. RIP uses
Okay.
one multicast address. EIGRP uses one multicast address, but OSPF using two multicast address, 224.0.0.5 and 224.0.0.6. So
Mm.
when DR other, when DR other will send up any update information to DR media, they will use they will use multicast address 224.0.0.6. You will see.
Yes.
It means when this DR have in this DR is trying to exchange update information to DR, for example. Okay,
Mm.
so it will send update with this multicast address. Clear my point?
Okay. Okay.
4.0.0.6. And when this DR, my point is when this DR will send this update to other DR router, DR to other DR routers, they will use multicast address 224.0.0.5. And you can verify this is not just a
Okay.
story, okay? You can verify
Okay.
it. Let me show you. Wait. You can verify here. Wait. So if I go to this R1 router, if I go to this, okay, let's capture this packet information. Packet information. Packet information. So here I'm trying to verify background process. Background process. So you can see R R1 R1 is sending update. This R1 is sending update to this multicast address. What? 224.0.0.5. You are getting only 224.0.0.5, 5, 5, 5. You are not getting any update with 224.0.0.6 multicast address. You will see, right?
Yes.
You
Ah,
are,
okay.
point is, you are only getting updates with this multicast address, dot 5.
Mm.
Where is the dot 6? I'm not getting any dot 6 information. 224.0.0.6.
Yeah.
So if you remember our theoretical portion, if you remember our theoretical portion, when DR other, my point is what? When DR other will send any update to DR,
To the.
they will
Okay.
use this multicast address. So what I'm
Mm.
doing right now, I'm not getting any new update from any DR other router.
Mm.
So here into this design, what we have, show IP OSPF. We have only BDR and DR. There is no DR other. There is no DR other.
Okay.
Show IP OSPF. There is no DR other.
Mm.
Okay, so let's create a design. Give me 2 minutes. I want to show you this. This is not just a story. Okay.
Yeah. Mm.
Into this design, I am using one router as a DR, one router as a BDR, and one router as a DR other. So let's try to configure IP address here. R8, we can configure IP address into this design. Interface fast Ethernet 0/0 192.168.10.1 mask no shutdown router. Okay. Let's go to R9. One 92, 168, 10 dot mask. No shut. No shutdown. Let's go to R10. Interface fast Ethernet 0/0. 192, 168, 10.3 mask. No shutdown. Now router OSPF process ID 192, 168, 10.0 wildcard mask. Area 0. Let's go to R9 router OSPF process ID 192, 168, 10.0 wildcard mask. Area 0. Let's go to R8 router OSPF 192, 168, 10.0 wildcard mask. Area 0. UNC, can you hear me dear?
Yes.
Okay, show. Let's check here on R9. Show IP OSP of neighbor. Please wait, okay? They are in two-way state. Wait.
Mm.
Next start. Next start. Now full. So you can see now into this design. Wait, it's taking time. Now you can see. Into this design, this router is a DR, right?
Yes.
Router is a DR
Okay.
because of higher router ID. This router is what? BDR. And this
Yeah.
R8 is what? DR other. You
Yeah.
can check now. No problem. You can go to R9. You can go to R9 and you can use a command show IP OSP of neighbor, and you can see R1 router, this one router, this router is acting as a DR other. Yes, DR other. This one is acting as a DR. Yes, DR. Now what I'm doing, if I'm trying to capture the packet for R8 router, let's try to capture the packet. And what I'm doing, I'm trying to create a loopback interface here. Let's create some loopback. Interface loopback 0. For example, 8.8.8.8. So I'm creating a new loopback, new update. You can say router OSPF process ID 192.168. No, 8 loopback 8.8.8.8 wildcard mask area 0. When I press enter, this is DR other, you can see, right?
Yes.
This is DR other. See,
Okay. Now he's sending information to the router.
yeah. This is what R8 router sending update to this multicast status. Why?
Yes.
Because he has a new update, and
Mm.
this he's sending to DR router. You can click,
Mm.
you can open it. I hope it's clear for you. Okay, this is not just a story. You can
No,
verify.
it's good.
This is source IP, LSU update, LSU update 8.8.8.
Okay.
Clear now?
Yes.
You can see this is our topic. Now let's continue this topic
Uh,
tomorrow. Okay, so what we complete? DRBDR election, virtual link, updates, network type. Now tomorrow we'll focus on, wait. Tomorrow we'll focus on OSP of LSA type and OSP of stub router. Okay, let's discuss tomorrow. Yes.
Okay.
Bye, dear. Take
Thank you.
care. Tomorrow, same time. Okay.
Yes.
Bye.
Thank
Bye,
you.
dear. Bye. Take care.